In this video, we'll continue our discussion of 2.3 by working a few more examples, and these examples get pretty difficult, or messy rather, they're not too difficult. So first things first, it is the same that we've been doing in the past videos. I need a solution, general solution. I need I where it's defined, and then we need to just determine if they're transient terms. First things first, we need it in standard form. So I'm going to go ahead and put this in parentheses. I'm gonna put a negative x up here and a 1 plus x. And then I'm gonna do this times y. Just kind of makes it a little more obvious that that's there. Okay, and then we have to do x plus x squared divided by 1 plus x. But I want to go up here and do some math first because you'll see it gets much simpler. Each one of those terms have an x in it. So I'm going to go ahead and factor, which cancels, leaving me with a nice pretty x. Much easier to work with. All right, so mu, since it is first order linear, right? dy, y, there are no other y's, and it's first. That's the biggest one derivative. So we have e to the, and I'll go ahead and throw this out here, x plus 1 plus x dx. All right, this is going to take a u sub. So e to the negative, and then I'm going to, let's go ahead. Oh, yeah, let's do that. So the u here is 1 plus x, du is dx. And then this is where the trick is. X is also u minus 1. So if I go through and replace everything, okay, I get a negative, and we're going to u minus 1 on top over a u on the bottom, du. Now, this is a bit tricky. First, I'm going to rewrite. I distributed the negative. I just don't want to deal with it. So this is e to the, if I divide now, I get 1 over u minus 1 du. Now, this is a bit tricky. You could get to a worse answer if you were to just derive from there. But I'm going to go ahead and just convert back to save some time. So I know this is 1 plus 1 over x minus, and then I just leave that as a 1. And then now it's not du, but I know that I can just interchange them. So e, and then I'm going to have ln of 1 plus x minus x. All right, those can be separated. It gets me 1 plus x times e to the negative x, right? The e split with multiplication, e and an ln just kind of cancel each other, leaving me with that. All right, so that is what I'm going to multiply both sides by, and I believe we can just assume the 1 plus x, and just know, yeah, we'll deal with that. So let's go ahead and just do parentheses here. It's going to make our lives a little easier. Okay, multiplying everything, the left-hand side becomes that function 1 plus x times e to the negative x times y. And then all I got to do is multiply the other side as well. I got x times 1 plus x times e to the negative x. All right, this is going to require from there. Okay, if we multiply that out, all right, we're not going to get too much, it's not going to be simple. We have to integrate this left side. This is what I was kind of baffling about. I guess that's the wrong word. Whatever. All right, so I have that. It's not the cleanest. This is another integration by parts. So let's go ahead and do, and I got to do multiple because the vanishing term doesn't go away in one step or become a constant in one step. So this becomes plus or minus, derivatives, integrals, plus, minus, plus, minus, plus, minus, and then I put the vanishing term in the middle. Remember, vanishing means that it eventually will just go to 0. And there's my 0. So I'm going to erase the extra plus or minuses. And then I have to put e to the negative x. This is nice and easy to integrate. It's just back and forth. Okay, so my solution then, or on our way to a solution, right? This is going to be negative x plus x squared e to the negative x. And then remember, I'm doing this. and there, all multiplied but added together each one. So I get a minus then 1 plus 2x e to the negative x. And then our last term is going to be a minus 2 e to the negative x. All right, I'm going to multiply everything by e to the x. So this gives me 1 plus x y. And then this becomes negative x plus x squared minus 1 plus 2x minus 2. All right. I guess we could start dividing if we'd like. Remember that this thing here, if I factor out an x, it's x plus 1x. So when I divide, dividing everything by it, I'm just going to get a negative x for the first term. Minus, I got to divide this one. So I'm just gonna, I don't think it cleans up at all. Please do not mark out the ones. This is, we're far enough now that you guys aren't splitting the plus signs. Please don't do that. Okay, minus 2. And oh, we forgot to put a plus c there at the very end. So this is going to get a c. That's a c. This is going to be e to the negative x. So we still have that e to the negative x there at the end. Or it's going to be a positive x because that's what we multiplied to get rid of all the negatives. There we go. All right, so there's our solution. Nice and pretty complicated. And then so I is going to be, I can't plug in a negative 1, right? Because I divided by 1 plus x to begin with. So I'm going to do negative 1 to infinity. You could go the negative way if you'd like, but the reason I'm going the positive way is because right here, right, I dropped my absolute value. So I want to make sure I stay in the positives because the negatives are going to make it not true. All right, so there's that. And then the transient, remember, are the terms that go to 0 as x goes bigger, which is going to be not that, that actually gets big. There are none. So the only way that would be if I had a negative, but I don't. So there's our I, and there's our transient term. Okay, I hope that's okay. It's these problems, even when I'm working this out, I plenty of racing. You guys don't get to see all that because I work it out before I actually record it. But give yourself some grace. These are very complicated, and then I think like one little mistake throws things off. Like I didn't do that up here at the top at the beginning, and it made it much worse, and things didn't work out nice and pretty like it did here. All right, one more for this video. Same directions, find a solution, find I, and then determine any transient. This is first order linear. We got to be good at recognizing that. And that's what makes this class extremely hard is you're going to do the homework and all of them are first order linear. You're like, great, I got that down. And then you go on to the next one, which is called exact equations. We'll get there and you're like, okay, I get that down. But what you have to practice is actually being able to identify what it can do. So the first things first, when I'm looking at this, I'm trying to see, is it separable? No, it's definitely not separable. There's a plus sign between terms. I need a term and a term on both sides. That way I can split them. This one is definitely not, but it is first order, dy dx, and it is linear because those are my only y terms. All right. First things first, we got to put it in standard. So we get, oh, hey, this is a mistake. Yours is probably fixed, but I ran in circles for a long time realizing I wrote down the wrong problem. My luck. Okay, so that's a cube. So when I divide then, I'm just going to get a cosine left over sine. And that's really cotangent, but I'm going to have to change it back in a minute, so just leave it. And then this side's going to become, I'm dividing by cosine squared and sine squared, so I'm going to get secant squared and cosecant. Now it's in standard form. All right, mu is e. I'm going to put an x there. I like that. E to the integral of cosine x over sine x. If I would have went to cotangent, you would have changed it here anyway to do u sub. Maybe you can see the u sub. If sine is u, then du is cosine dx. Or yep. So it actually just takes it right away. So this is actually e to the ln of sine. All right, and that's going to create just a sine. Nice and pretty. That's why we left it. You could have used, I think when I first tried this problem, I used like the table to get my cotangent and it got messy fast. So anytime you can find these little u subs, they're gonna make your life a little better. All right, so there's mu. I'm gonna multiply everything, but remember the left-hand side, I'm just gonna go ahead and jump to the product rule. This is sine x times y. And then I have to multiply the other side by sine. Well, this is 1 over sine, so those things cancel, leaving me with the secant squared, which I'm really happy about. Okay, then we integrate. I get sine x times y, and then the integral of secant squared x. And why we're happy about that is that's a nice, pretty tangent, x plus c, right? And then we're going to divide by sine. So tangent divided by sine, sine over cosine divided by 1 over sine, that's going to cancel, leaving me with 1 over cosine, which is secant, plus, and then this is just going to have a c times cosecant, right? So there is that. Oh, let's discuss anything else. Okay, for I is a bit complicated here. We have we're stuck with these two things here. And remember that those are the, like, okay, for cosecant, which is based on sine, it's like this, those, right? With this like asymptote going through those. And then cotangent's like the opposite, or not opposite, but moved forward a little bit, right? So it's like a something like that. And that happens right here. That's at pi over 2 when those happen. And then this is at pi over 2, and it would have an asymptote. So the only spot that those two things are going to be defined together would be right there. Let me go show you on a graph, because that doesn't look good. Struggling. Hold on. Cool. Okay, so I'm going to go ahead and go to y equals, clear it, and then I'm going to go ahead and put this function in. Secant, so we got to be 1 over, oh, let's clear this, equals, and then we got 1 over cosine x, close it, plus, and then I'm just going to let c be 1. I'm not going to change it. That's going to be 1 over sine x. Right? So it looks weird there. See, that doesn't really tell us anything, right? We can't see it on here. I can't see that I need 0 to pi over 2 only. And it looks like here we could just do 0 to infinity. You have to be careful that you look at all the problem. The whole problem is not only that, but it's interesting that we get values here when they should be undefined at certain values. Oh, I bet if we zoom in, it causes issues, maybe. Yeah, I bet they're holes or something. So let me go back real quick because I want to show something to you. Let's do these separate. So 1 divided by that and 1 divided by sine. So this is just looking at each one of these. Go to y equals, they're both on. Hold on, I think maybe I'm in degrees. Okay, that's why nothing was looking right. Oof, okay, so there is our cosecant and our secant. So see that everywhere there is like the straight lines, those are asymptotes. So the blues have an asymptote in between each one of them, the orange. So the only thing that's going to be okay is between 0 and that asymptote, and that happens at pi over 2. Um, let's try to plug in the function because I'm curious now if it will show the right one that I was just in the wrong angle. So, oops, y equals 1 over cosine x plus 1 over sine x graph. There we go. So you can see that all those inconsistencies. So the 0 to pi over 2 is the only thing that's going to work. We also have transient terms, and remember, those are things that go to 0 as x goes forever, and that's not going to happen here, right? Secant and cosecant, you can see how they are producing things. It's never, nothing goes to 0, right? I don't see anything flying down. So here we go. There's our solution for that one. Don't be scared of the trig. I think this makes it hard, but I think everything else, I expect you guys to be able to do. It's just dividing by signs and stuff like that. It's really shouldn't be anything past what you guys are capable of. Anytime you have these weird formulas in your homework or in my videos, on test, if something like that were to pop up, I'm going to give you that formula at the beginning of the test, so that way you know you have the resources you need. But there won't be a table. You won't get anything like that. So, yeah, there we go.